Okay, so there hasn't been much visible progress on the openaltimeter front in the last few weeks, and I thought I'd just give you a look at some of the behind-the-scenes stuff that's going on at the minute. And so these are openaltimeters back from the factory. This is what they look like when they come back. This is anti-static packaging. And the key thing that needs to be done before they can be sold is to test them. And so in this video I'm going to show you a little bit about how each altimeter is tested before it's sold. And so the all-important thing is this little jig, and so this is what's called a bed of nails jig, and you can see these golden contacts, they're sprung-loaded. And so how it works is the board sits in this little hole and then pushes down, and it springs down onto those contacts, and they make a temporary electrical connection with the contacts on the bottom of the board. And somebody asked on the forum, somebody noticed that there are, I think it was Benjamin, that there are an extra set of contacts on this side of the board that don't get used. And actually you'll see what they're for here. They're for initially programming up the chip. So let's connect this jig up and see how it works and what the test sequence is for each openaltimeter. And so the jig has a connection for the serial downloader. It also has a connection for this thing. This is an Atmel Dragon. So this is a low-level programmer that can really talk directly to the flash chip. And what it's going to do is it's going to put the bootloader on. And once the bootloader is installed on that chip, then it can be used with the Arduino software. But until it's got that bootloader, it won't do anything. And then finally we have a little LiPo and a regulator just to provide power to the test rig. There we go, so we drop the unit under testing, just make sure it's in tight. Okay, so we can now power that up. And absolutely nothing should happen. It doesn't make the beep noise that you're used to. In fact, it's just sitting there doing nothing because that microcontroller chip is completely blank. And so the first thing we needed to do is to talk to the microcontroller and put a bootloader on it. And so what this script does, I probably can't read the screen here, but it's first of all programming the flash memory on that chip, and it's just installing about 2K of code. So it's a 32K flash memory on the microcontroller, but it's installing about 2K of code, which is a bootloader, and that's a program which will run as soon as the chip starts up. And it's that program that listens for commands from the Arduino environment. So that's what makes it so easy to use. The presence of that bootloader means you don't need any of this fancy stuff. You just need the simple Arduino programming dongle. It also, like I say, I don't think you can read this, but it also does what's called setting the fuses and setting the lock bits on the chip. And so what that does is it configures the chip at a very low level. For instance, where is it getting its clock signal from? And it also locks the chip so that you can't accidentally overwrite the bootloader, because if you were to overwrite the bootloader, then you'd need one of these to get out of that pickle. So that all seemed to work. And so now this board is now an Arduino, if you like, or it's now Arduino compatible. It'll now listen for Arduino commands. So if I go into my Arduino environment and try and upload the latest version of the firmware, we should see that it behaves just as you'd expect, which is the little lights will start flashing in a moment, and it should talk back and forth and upload. Yeah, there we go. And now if everything goes well, once it finishes uploading, we should hear it boot up and introduce itself with its characteristic beep. There we go. So grossly, we'd say that's working. It's accepted a program. I can see the little light flashing, meaning it's logging there, and the beeper works. But before this unit gets sent out, obviously we want to do a real thorough test of all of its systems. And so to do the full testing, to make sure every piece of hardware on that board is working, we have another little program, a custom written program. So I can hit this run tests button and it'll connect up to the altimeter. We should hear it beep, there we go. And it'll start running that test sequence. That test sequence takes a couple of minutes, but what it'll do is it'll check every single byte of the flash memory to make sure that they're all working. It'll check the pressure and temperature sensors. It'll make sure the voltage sensing circuitry is reading a sensible voltage. It will check the radio input. This receiver here is listening to my radio, so it's really a real-world test to make sure that the radio works. And then it'll log for about a minute, at an accelerated rate actually, but it'll log about a minute's worth of data, and then that data will be plotted up on this display here. And in fact, that data, I save it out, and you can, for every unit, you can go on the website and download its test data, so you can really see how your unit performed under test. Like I say, it takes a couple of minutes, so we'll skip ahead. Okay, so the tests have finished, and you can see it's passed. We've got a log of the last minute or so of data there, and you see that the noise on the sensor looks good. We've got a noise of about plus or minus 1, a little bit less than plus or minus 1 foot of altitude resolution here, and so that comes within the parameters that I consider a pass. And so, yeah, I hope that's interesting. That's the little test routine that every altimeter goes through. Like I say, everyone will run through this routine, and then all the information is up on the web, so you can really see for your particular altimeter how it performed in test.